Hello and welcome back to part 2 of the Bebras Challenge Island Research Expeditions. In this video, we're going to solve the challenge from part 1 and figure out the minimum number of research trips needed to visit every island. If you haven't watched part 1 yet, pause the video here and go back to see the explanation of the challenge before continuing. Let's work through it together.
Since the team must return to their helicopter, they can only visit islands where they can travel and still come back again using the ferry. So we need to look for groups of islands where you can travel from any island to another and also come back again to the starting point. Inside these groups, the team can move around freely using the ferry following the arrows, visiting as many islands as possible and still return to their helicopter.
Let's try to find such a group by selecting a random island and see how we can move around. While doing so, we should keep track of all the islands we've already visited, so we don't forget the path we have followed so far.
Say we pick Island D. From this island, we can choose to either go to Island F, E or C. Let's go to F. From F, we can go to E or G. Let's pick G. So that means so far we visited D, F and G. But there's a problem now. We are stranded on G because we cannot take any ferries to D or any other island. That means this is not a correct group.
This is something that happens a lot when you're solving Bebras challenges. You try an idea and then you realize you're stuck and that you need to try other alternatives to try and solve the challenge. That's actually a big part of how computer programmers solve problems too. Let's rewind a bit and consider another island.
Say this time we go to E from F. However, now we have the same problem. There is no way to get back to our starting point, which was Island D, where we landed with our helicopter, so this is also not a good group. Let's go back to Island D. We still haven't investigated where we would end up if we went to Island C. As you can see, if we follow this path, we can easily get back to D by going to Island A and then Island B. So we have managed to find our first group.
But what about the other 3 islands?
If you remember from our second attempt at solving this challenge, we saw that we could get back to Island F from E. So let's leave Island D and visit Island F with the helicopter. Now we can visit Island E with the ferry and also go back to F, where the helicopter is waiting. So this is also a second group. And what about Island G? Well, we'll have to visit that island individually with the helicopter, as otherwise there would be no way of getting back to the starting island from G, since there are no ferries going out of the island.
So this means we found a total of 3 groups. Some people might think that the team could just take a long journey like this.
C, A, B, D, F, E and G. This path visits every island, but there's a problem. At the end of the trip, the team can't return to the starting island to reach their helicopter, so that plan doesn't work. So since the islands form 3 separate groups, the research team needs to go on 1 trip for each group of islands.
That means the minimum number of research trips is 3. Let's remind ourselves how we solved this.
To find a group, we first picked a starting point. Then we followed every path possible. Once we found a group of points where we could travel back and forth to the start island, then we found a suitable group. And that is why we needed 3 research trips. The first trip is the big loop of A, B, C and D. The second trip is the 2-way street between E and F. And the third trip is the dead end at Island G.
That was fun, wasn't it? I remember when I first started getting interested in computers, puzzles like this were my favorite. To solve this challenge, you used computational thinking. You focused on the connections between islands to find groups. And you used algorithmic thinking to come up with a systematic way of finding these groups, to find the minimum number of trips required to visit all the islands. This is exactly the kind of thinking used in computer science and network analysis. So if you enjoy challenges like this one, you might already be thinking like a computer scientist. If you want to try solving another challenge, you can find more challenges like this one on our YouTube channel. Thanks for solving this challenge with me, and I'll see you in the next one.